Turn off the mic. Okay, so this annuity pays $50 at time 16, $50 at time 26, and this keeps going on for, let's say, 8 years. Annual interest rate, or I can make it a little tougher, okay? I can say semi-annual, nominal interest rate convertible semi-annually, 4%. Find the present value. So I don't want to get caught up in all the math. What I want to do is talk about the steps to make this happen, okay? What do you say? Nominal interest rate convertible semi-annually 4%. So that means what? I want to do method 2 because method 1 is doable, right? Let's concentrate on method 2. So what do you say? What are the steps? Can you outline them for me? What's the game plan here? I want to find the total annual payment. I also want to do it at what interest rate? Annual interest rate. So the first thing I have to do is do I2 over 2 equals 2%. And then I'll find I. 1 plus I equals 1 plus I2 over 2 to the 2. And then bring the minus 1 to the other side. So I equals 1 plus I2 over 2 to the 2 minus 1. Never mind what it is. I don't care what it is. Leave it alone. Now what do? I have an annual interest rate, I annual. Now what? Present value equals what? What's the symbol? That's all I want. What's the symbol? A angle 8 years, happening 6 times a year, at the annual interest rate I, call it I annual. And let's not forget the coefficient, right? What is the coefficient? 50 times 6. Is that what you said? Okay, 50 times 6. So this is the annual amount. Okay, everybody clear on this one? What if this payment was happening beginning time 0? What would change? Same kind of annuity, 8 years, last payment happening here. First payment happening here. What would change? Present value equals what? Yeah. Yeah, A double dot, angle 8, still I, still 6, still 50 times 6. So what's the difference between this one and this one? This one is equal to 1 minus v to the 8 over I6, and this one, of course, times 300. And this one is equal to 1 minus v to the 8 over d6 times 300. You see the difference? Okay, what about accumulated value? So let's call this A, and let's call this B, and let's talk about accumulated value of A. And let's try to fit it in here. Accumulated value equals what? Not A angle, but, yeah, S angle 8, I 6 times 300. So what do you think that formula should be? 1 plus I to the 8 minus 1 over I6. Meaning, it's just this one. I have taken the present value and multiplied by 1 plus I to the 8th power. So can I go like this? 1 plus I to the 8th power to get from present value to accumulated value. Are you understanding me? And the same thing on the bottom, right? Accumulated value equals 1 plus I to the 8 minus 1 over D6 times 300. So again, to go from present value to accumulated value, multiply. Right? Okay, so I don't know if it's worth, why don't you right here refer to formulas that will be scanned. Okay, and I'll scan this page. This is the page of formulas which I will scan. Okay? So instead of sitting here and copying them, which is silly, we'll scan them. Just remember that the coefficient in every case, coefficient in every case is the annual amount. Okay. Let's do a problem. Example, it's not in your notes. A perpetuity immediate provides monthly payments of 500. Annual effective interest rate equals 0.06. Find the present value. This time it's a perpetuity, not an annuity ending at time n. So timeline, 1/12 pays monthly. So time 1/12, 500, time 2/12, 500, and so on, forever. Okay, so my old method that I keep getting tempted to revert to, so method 1 would give me present value equals 500 over I monthly, and I would be done. Right? So I monthly can be found by going 1 plus I 1/12 to the 12 equals 1.06, and then solve. Solve for I 1 over 12, which gives me 0.0048675 ... Okay, so if I did that, my method 1 would be done. How about method 2? So this would be present value equals the annual amount, so 500 times 12, 6,000. A angle infinity 12, I at the annual rate. The only thing different here is that instead of writing 8 years or 10 years or 12 years, I wrote infinity, which is equal to 6,000 A angle infinity. And then I'm going to arrange for this monthly payment, so times I over I-12. You can do that. What's A angle infinity? Yeah, this one is 1 over I. So basically it's 6,000 over I-12. So I-12, be careful, is going to be 12 times this amount, right? When all is said and done, I get 6,000 over 12 times 0.0048675. This goes in 500 times, and then I get 102,721.07. So A angle infinity M is equal to 1 over IM. And A double dot angle infinity M is equal to 1 over DM. What's the difference between A double dot angle infinity M and A angle infinity M? What is it? What is it?
One time period of payment.
Yeah, one payment, right? Because this one starts now. This one starts one period from now. So the only difference between these two present values is the present value of the first payment, which is itself. So A double dot angle infinity M minus A angle infinity M equals 1 over M. Where's the first payment? Of 1 over M at t equals 0. All the rest of the payments are the same. So this is, here's a monthly paying perpetuity immediate and monthly paying perpetuity due. Just have to keep it straight, because here what's going to infinity is the number of years. In 5 minutes or 10 minutes, we'll be talking about something else going to infinity, that something else being M, where the payments now become continuous. So M will go to infinity, so you want to keep it straight. Okay, next page. I think Shirley, right? Yeah. Shirley deposits $1,200 at the end of each quarter for 6 years in an account paying 5%. Okay, so method 1, 6 years, that means 24 payments of $1,200 every quarter. 1, 2, 3. Oh, you can't see. I'm sorry. Thank you. 1,200, 1,200 every quarter. And this keeps on happening. So there are 24 payments. So what do they want? Find the accumulated value. So accumulated value equals what? 1,200 S angle 24 I. I which? I quarterly. There are 24 payments, but the period is a quarter. The payments are happening quarterly, so the interest rate has to be quarterly. So I annual was 5%. 1 plus I equals 1 plus I 1 quarter to the 4th. I'm looking for I 1 quarter, so 1.05 to the 1/4 power minus 1 equals I 1/4. This turns out to be 0.122722344. And that's this I that I'm using here, I quarterly. So 1,200, 1 plus I quarterly, that's right, 1/4, to the 24 minus 1 over I 1/4. Turns out to be 33255.13. That was method 1. How about method 2? Talk to me about method 2. What is the annual payment? 1,200 4 times a year, right? So 1,200 times 4 is the annual payment, 4,800. A angle, how many years? Right, how many times a year? What is the interest rate? Careful now. Annual, 0.05. Let's clean this up. 4,800. 1 minus v to the 6 over what? I4. So I4 is just 4 times the quarterly rate, right? When you clean this up, what do you get? This is present value, by the way, right? They're asking for accumulated value. So let me find present value, and then I'll just forward it, right? So present value equals 24. Yeah. Is that what you wanted? Losing? $24,815.49 is the present value. I don't want the present value, I want the accumulated value. So what should I do? Present value times 1.05 to the 6th power. Make sense or not? Same answer. So let me say here, present value equals. Or I could have gone directly, right? Nobody said you have to find the present value and then grow it. You could just go S angle 6 4 at 0.05. Any questions? Next one. Next page. It is reported that the present value of an annuity paying $2,000 at the end of each year for X years, okay, X years, paying $2,000 at the end of each year, it is reported that the present value of an annuity paying $2,000 at the end of each year for X years is $12,000. So 12,000 equals what? Can you give me an equation? Hello, hello? 2,000 A angle X. Did they talk about an interest rate? They're saying it's a single interest rate and we don't know what it is. So A angle XI. That's the first equation. Then what? It is reported that the present value at the end... Wait. It is reported that the present value of an annuity paying $2,000 at the end of each year for X years is $12,000. And that the present value of an annuity paying $300 at the end of each year for 4 years... $300 at the end of each year for 4 years is 1,000. So 1,000 equals 300 what? A angle 4I. And then what? Find the present value of an annuity paying 1,000 at the end of each 2-year period. So here I go, 1,000 times 4, 1,000 for X years. What do you say? Equation, payments happening less frequently than interest is credited. I want the present value. The present value equals what? I'm just looking for the formula, nothing more. Look, they're asking for present value, so your numerator is going to be A. A angle X I divided by the payments are happening at the end of every 2 years, S angle 2I, where I is annual. Agree? So between this one and this one, so here I can find I. Once I find I, I'll find X. So here, find I. Using I, find X, and then plug. Are you with me? Shall we do it, or shall we go on to something more? You can do this, right? You can get through this. So here, the only unknown is I. After you find I, use that I here. The only unknown will be X. After you find I and X, go and plug in here. Finished. So 1, 2, 3. Everybody okay with this? Okay, next one. Annuities with payments less or more frequent than interest period and payments in arithmetic progression. So your book has formulas for each of these things. I'm resorting to method 1 for this one because it's that increasing annuity, arithmetic, instead of memorizing more and more and more formulas, okay? So a loan for $50,000 is to be repaid by end of year payments for 10 years. Okay? Timeline. Loan L. Thank you, Brandon. By end of year payments for 10 years. So first payment and last payment at time 10. The first payment is $500. And each subsequent payment increases by Q. So the next payment at time 2 would be 500 plus Q. The third one would be 500 plus 2Q. If you don't mind, I'm going to make this timeline a little longer because later they're going to ask me for OLB 5, so I need room. So let me keep going, make this 10. So the 10th payment will be 500 plus 9Q. Okay. Find the smallest value of Q which suffices, and then find the OLB just after the 5th payment. So here's OLB 5 after the 5th payment. Assuming the debtor is being charged nominal interest rate convertible monthly. So these are annual payments. The interest rate is given monthly. So the first thing I'm going to do is take this I-12 over 12, which is 1%, and I'm going to find my annual interest rate. 1 plus I equals 1 plus I-12 over 12 to the 12th power. And this produces, let's see, what did I get? I equals 0.1268253 annual. Then I have to set up an equation for my L such that I can solve for Q. So what is the loan amount? 50,000 equals, what kind of annuity is this? Arithmetic annuity. Do you have a formula for the present value of an arithmetic annuity? And if so, what is it? P A angle N I plus Q over I A angle N I minus N V to the N. Arithmetic. So let's plug in 10. So 50,000 is equal to, my P is 500. 500, A angle 10. I have an I to work with, I annual, plus Q over I, this I that I found here, A angle 10 minus 10 V to the 10. I have to solve for Q. So let's bring this mess to the other side. 50,000 minus 500, 1 minus V to the N, which is 10, over I, equals Q, and let's then divide by this term right here. I times A angle 10 minus 10 V to the 10. I brought this term to the left side. This Q, when you do that, turned out to be 2430.29. Once you know that Q, we then work for OLB 5. So can you give me an expression for OLB 5? Let's do prospective. What's this first payment right here? $500 plus 5Q, and I know Q, and so forth. Increasing, right? Still increasing. So let me take the present value of the remaining payments at 5 after the 5th payment. So what would that be? I, P, Q. It's an increasing arithmetic. A, angle. How many payments are left? You've made 5 payments and 5 payments are left. 5. And the interest rate is the annual interest rate, I, annual. Where P, the first payment, is this guy, 500 plus 5Q. And Q, the increase is just Q, which is 2430.29. And the formula, P, which is 500 plus 5Q, A angle 5I, plus Q, 2430.29, divided by I, times A angle 5I minus 5 V to the N, so V to the 5. This is equal to OLB5. So let me write here OLB5 equals. And then clean this mess up. Plug in your Q here and stuff. 2430.29. So doable. Next one. Justin deposits 100 into a savings account, paying 5% at the beginning of each year for 10 years. Timeline: 100 at time 0, and this goes on to time 9. Last payment at time 9. The interest earned from this account can be withdrawn. Oh, by the way, let me write here, this one gets 5% interest rate. The interest earned from this account can be withdrawn at the end of each year and reinvested into another account earning 4% interest. Okay, so the next account earns I equals 0.04. And we're talking about interest. Okay, so let's talk about time 1 right here. How much interest on $100 at 5%? $5, right? So 100 times 0.05, which is $5. At time 2, you have two $100 now at this time, and that grows by 5%. So this would be $200 times 5%, $10, and so forth. What do they want? Find the accumulated value of his holdings in both accounts at the end of 10 years. Okay, so total accumulated value. What is the total accumulated value of the first account, bearing in mind that all interest has been pulled out? 1,000, because there are 10 payments of 100. 10 times 100, which is 1,000, plus what? The accumulated value of the second account, right? So that's an increasing annuity. P is 5, Q is 5. So let's write that as I increasing. P is 5, the first payment here is 5, right? And the increment is also 5, so 5 comma 5. S, angle 10 at 4%. 4%, not 5%. That second account is only getting 4%. So 1,000 plus 5, S angle 10, I'm plugging in the formula, 0.04, plus 5 over 0.04 times S angle 10, 0.04 minus 10. This one has no V to the N term because it's accumulated value. So S angle 10, 0.04 is 1.04 to the 10 minus 1 over 0.04, and that is 12.006. Plug that into that equation up top, and you get 1310.79. Everybody okay? Is there any part of this that you do not understand? Okay. Let me ask you this. If this is time 1, this is time 1/2, and I deposit $500 here, and I deposit $500 here, what is the interest for the first year? I should say for this year. What is the interest for this year? Can you think carefully and give me an answer?
Wouldn't it just be the difference between 500 grown to 1 from time 0 and a half grown to time 1?
Let's grow it. Let's say your interest rate is nominal interest semi-annually, nominal interest semi-annual converted semi-annually of 4%. So I'm saying that I2 is equal to 0.04. So I2 over 2 equals 2%. So that's my 6-month rate. So go ahead, grow it for me, will you? 500. Let's grow this to time 1. Go.
Wouldn't it just be 500 times 4.02?
To the
So I can pull it up second.
second power. Okay, I grew it. Then you want to go the other one?
500 times 1.02.
Okay, then what do you want to do? I only want the interest.
Wouldn't the interest just be, we need to factor out the 500 that total?
Hmm. Can I look at them individually? What is the interest on this, guys, on this 500? Can I say 500 times 1.01 to the second power minus 500? That would be the interest on this money. And then 500 times 1.02 to the first power minus 500 would be the interest on the second payment. So when all is said and done, can I go like this? 500 times 1.02 to the 2 plus 1.02 to the 1 minus 500 minus 1, like that. Can I do that? So how about this? 500 S double dot angle 2 at 0.02 minus 500 times 2 minus 1,000. Would that be fair? So even though the 500 payments are happening at 2 different times, you can just take the accumulated value, I did double dot because the payments are occurring at the beginning of the period, minus the 2 payments of 500. Do you get what I'm doing? I need you to get it because I'm going to assign you an extra credit to take home. So I need you to ask me now if you're not getting what I'm saying. Because I'm only interested in the interest, I took the accumulated value of this 500 and I took away 500 from it. Then I took the accumulated value of this 500 and I took away 500 from it. Then I factored out the 500 and I said 1.02 squared minus plus 1.02 to the 1. So this one plus this one. And then I said, well, this one is just equal to S double dot angle 2 at whatever interest rate. Minus these two 500s, 1,000. So this will come in handy for the extra credit that I'm about to assign you. Should I make you do it in the next 8 minutes, or should I let you go home and do it? I think so too. So your extra credit is to just go to the very next page and do that next problem.